Welcome back to the Deep Dive. Today we're diving into something pretty universal, this constant quest for balance.
Mm,
We all seek it, right?
mhm.
Whether it's, managing money, staying healthy, keeping calm, or just handling the everyday stuff. We're always kind of tweaking things, trying to find that equilibrium.
Yeah, that sweet spot.
Exactly. And what if AI could, well, seriously help with that? That brings us to Balance AI. It's maybe a theoretical idea for now, but think of AI systems designed as these uh, super sophisticated regulator.
Homeostatic regulators, yeah.
Right. Their job to keep an eye on complex systems could be your personal finances, could be the global economy spot when things are drifting, and then step in. Recommend or maybe even make changes to get things back on track,
Yeah.
like a smart governor for, well, almost anything.
What's fascinating here is just how broad this could be, because equilibrium, balance, it's fundamental to basically everything.
Everywhere, yeah.
Your cells managing glucose, markets finding stability, ecosystems staying healthy. So an AI that gets balance, that's huge. It could apply at like any scale, your own habits, your work-life situation, all the way up to big economic indicators or, planetary health data.
A constant push for stability in a world that's always changing.
Precisely.
And that's our deep dive for you today. We're going to explore this concept, how it works, the different ways it might be used, and importantly, the big questions it raises, hopefully give you a real shortcut to understanding it. So let's start at the beginning. This idea of equilibrium, homeostasis, it's not just a nice metaphor we're sticking onto AI, is it?
No, not at all. It's fundamental. You see it in biology, blood sugar regulation, like I mentioned. Psychology, too, our mental well-being.
Right.
Economics relies on it for market stability. Political science talks about the balance of power. Ecology is all about ecosystem health. It's baked into how things work.
And Balance AI taps into that fundamental principle.
Exactly. And, it builds on older ideas, specifically cybernetics.
Cybernetics. Right. Feedback loops and self-regulation.
Precisely. Cybernetics explored how systems of biological, mechanical, social use feedback to stay stable. The classic example is the thermostat, right?
Yeah. Senses the temperature, adjusts the heat. Simple.
Simple concept, but powerful. What's changed is that today's AI, especially with machine learning, has the sheer computational power to apply those ideas on a scale and complexity that was, frankly, unimaginable before.
So it's a shift. AI isn't just doing tasks anymore. It's becoming a continuous sort of dynamic guide for whole systems.
That's the potential leap, yes, from task doer to system governor.
That feels like a big jump.
Yeah.
How does this dynamic governor actually work? How does it sense things are out of whack and decide what to do?
Okay, so first, we need to understand that these advanced AIs, they are complex adaptive systems themselves. CAS, for short.
Meaning they're not just simple tools.
Right. Think more like an ecosystem. Their behavior isn't always linear, predictable. New abilities can just sort of emerge. Small changes can cascade in surprising ways. And that's crucial because when one complex system, the AI, is regulating another complex system, like your health or the economy, it's not just a tool acting on an object.
It's two complex systems interacting.
Exactly, which can create all sorts of unexpected feedback loops and behaviors. Designing balanced AI means grappling with that inherent complexity, that interaction.
Right, so these complex AIs interacting with complex systems, they're going to create feedback loops and be affected by them too. This is where it gets really dynamic, maybe unpredictable.
Absolutely. Feedback loops are central to how any complex system regulates itself. You've got positive loops, the ones that amplify things.
Like a snowball effect.
Kind of, yeah. And negative loops, which are stabilizing, they dampen things down. Now, modern AI, it's not just subject to these loops, it actively creates them in the world.
Okay, give me an example.
Think about performative prediction. An AI predicts, say, housing prices will rise. People see the prediction, maybe they rush to buy, which pushes prices up. The AI sees prices going up, reinforces its prediction. It can become a self-fulfilling prophecy.
I see. Or like content recommendations. They show you more of what you like.
And suddenly you're in an echo chamber, right?
Right.
Narrowing your perspective. That's an amplifying loop.
So a balanced AI has to be smart enough to see those potentially harmful loops.
Yes, and dampen them down, while at the same time identifying and leveraging the stabilizing loops to gently nudge the system back towards a healthy equilibrium. It's a sophisticated balancing act in itself.
Okay, so if feedback loops are like the currents in the water, then control theory. That sounds like the AI's rudder and navigation system, moving it from just watching the currents to actively steering.
That's a really good analogy. Control theory is essentially the engineering discipline that provides the nervous system for this.
How so?
At its core, it's about designing algorithms that let an agent, the AI in this case, make optimal decisions to maintain stability, even when things are uncertain or changing. The process is usually sense the environment, compare the current state to where you want it to be, the equilibrium, and then calculate the best action to shrink that difference. Yeah. Sense, compare, act. Over and over.
We see that already, don't we? Like smart traffic lights.
Exactly. Dynamically adjusting signals for better traffic flow. Or autonomous drones navigating tricky spaces, or robots optimizing movements on an assembly line. That's AI-driven control theory. For balance AI, it provides the framework to turn, imbalance detected, into, okay, here's the precise action needed. But, and this is a really profound challenge, the moment the AI starts trying to guide the system, it becomes a new player in that system.
Right, it changes the game.
And other players, people, markets, whatever, they'll adapt. They'll react to the AI's actions. You know, like when you set a really strict budget app.
And suddenly you find creative ways to justify that extra coffee.
Exactly. You game the system, consciously or not. That human adaptation creates new feedback dynamics. So a truly effective balance AI can't be rigid. It can't just command.
It needs to learn from that reaction.
Precisely. It needs to be meta-adaptive. It has to model not just the system's state, but how the system reacts to being controlled. It's more like a learning partner than a strict commander.
That's a crucial difference.
Yeah.
And for it to be a partner, it needs good eyes, right? It needs to actually see these imbalances. How does it manage that kind of pattern recognition?
It's typically a pipeline, a series of steps. First up is data collection. Just pulling in huge amounts of relevant data. Biometric readings, calendar stuff, satellite images, market data, whatever fits the domain.
However, raw data.
Then feature extraction. This is about pulling out the important signals from all that noise. Not just the raw numbers, but maybe statistical things like how fast spending is changing or specific sound frequencies from a machine that hint at wear.
Finding the meaningful bits.
Exactly. Next comes pattern detection, using algorithms to find structures in those features, clusters of similar behavior, trends developing over time, or maybe anomalies, things that stick out like a potentially fraudulent transaction. And finally, classification and decision-making. The AI puts a label on the pattern, high burnout risk, market showing volatility, ecosystem stress detected, and that triggers an action, an alert, a recommendation, maybe an automated adjustment. And because equilibrium isn't static, it's dynamic, Balance AI needs tools to understand patterns over time. That's where you get into more advanced models, things like LSTMs, long short-term memory networks, and especially transformers.
Transformers, right. They're powerful for language, but other things
But
too.
yeah, their self-attention mechanism is incredibly good at spotting complex, long-range connections in sequential data. Think forecasting traffic flows, volatile financial markets, or predicting climate shifts. They help the AI anticipate, not just react.
So it sees the pattern, maybe even anticipates it. Then what? How does it decide the best way back to balance?
That's where optimization algorithms come in. They're the tools that translate we're unbalanced into here's the most efficient strategy to fix it. Finding the best way to allocate a budget, the optimal delivery route, the most effective intervention.
Okay, this sounds incredibly powerful technically, but let's shift gears a bit to the human side. Because an AI can be super accurate, but if people don't understand it or trust it, it's useless, right? We hear about the black box problem all the time.
Exactly. And that's why explainable AI, XAI, is so critical for this whole concept. XAI is about turning those opaque black boxes into more transparent glass boxes.
Making sense of the AI's reasoning.
Right. It's not just one technique, it's a whole toolkit. For instance, you can get global explanations why the AI behaves a certain way overall, like your budget usually goes over because of dining out, or local explanations why it made one specific decision. This alert, it's because that $200 dinner pushed you over the weekly limit.
Okay, general versus specific reasons.
Yeah. And there are methods like LIME or Esche. These are model agnostic, meaning they can help explain almost any kind of AI model. But for Balance AI, something called counterfactual explanations can be really intuitive.
Counterfactuals, what are those?
They basically answer the question, what could I have done differently? So imagine that work-life balance AI flags you for burnout risk. A counterfactual might say, if you had scheduled 1 more hour of focus time this week, or attended 2 fewer meetings after 6 p.m., your balance score would likely be in the healthy range.
So it gives you concrete actions. That feels much more useful.
Exactly. It empowers the user.
So what does this all mean? It sounds like XAI isn't just a nice feature. It's fundamental for balanced AI to actually work in the real world.
Absolutely non-negotiable. You need it for user trust. You need it for debugging, figuring out when the AI gets things wrong. Increasingly, you need it for ethical and legal reasons. But ultimately, it's about the effective outcome. An explanation, even if it slightly simplifies the AI's logic, might be far more likely to get someone to actually adopt a recommendation and improve their balance than a perfectly accurate but completely mysterious answer.
Right. Adoption is key. Okay, let's talk applications. We've touched on a few, but
Yeah.
walk us through the range here from personal stuff up to bigger systems.
Sure. Let's start with personalized medicine. Imagine maintaining your unique health balance. AI could integrate your genetic profile, health records, data from your watch.
All that real-time tracking.
Exactly. To proactively spot risks or optimize treatments, take diabetes management. A Balance AI could monitor glucose, diet, activity 24/7, giving personalized, real-time advice on insulin or food to keep blood sugar stable. It's proactive wellness.
Makes sense. What about mental well-being?
Psychological equilibrium. You could have behavioral AI looking at digital patterns, tons of late-night emails, a super fragmented calendar as indicators of stress or overwork.
Things we might not even notice ourselves.
Right. Then it could intervene smartly. Intelligent scheduling tools like Clockwise or Reclaim.ai already do some of this blocking focus time, rearranging things.
Hmm.
Or AI chatbots like Wobot or Wysa offering coping strategies. The whole quantified self movement is basically building the data foundation for this.
Interesting. And in education.
Educational attunement. Think adaptive learning platforms. The AI tracks student progress, engagement, time on task, aiming to keep them in that sweet spot, the zone of proximal development.
Not too easy, not too hard.
Exactly. If a student's struggling, it might adjust the difficulty, offer extra help. If they're flying, it speeds things up. It could even help teachers by automating grading or admin tasks, freeing them up for actual teaching, balancing the cognitive load for students and the workload for teachers.
And personal finance. Feels like we're already seeing bits of this.
For sure. Personal financial management. Lots of fintech apps act like mini balance AIs. They connect to your accounts, spot things like subscription creep.
Those subscriptions you forgot about.
Yeah. Or patterns of wasteful spending.
Wow.
Then they give you budget advice, maybe automate savings transfers, suggest canceling things. It turns managing money from reactive to proactive, helping maintain that financial balance.
It's pretty amazing how it could fine-tune things on a personal level. But scaling up, can it really bring that kind of stability to massive systems like entire economies?
Well, AI is already making waves in macroeconomics. Think behavioral economics using AI to analyze social media sentiment to predict market shifts. Or detecting systemic risks, early spotting signs of volatility or potential supply chain breakdowns before they happen.
Okay, that makes sense. Prediction and early warning.
But here's where it gets tricky ethically. That same nudge AI uses to help you stick to a savings goal. Well, a company could use a similar nudge for their benefit.
How so?
Imagine a retail AI identifying when you're maybe feeling stressed or impulsive, cross-referencing that with items you've looked at, and hitting you with a perfectly timed, personalized offer to trigger a purchase. It could actively disrupt your financial balance for their profit.
Wow. So it sets up a kind of battle of AIs.
You could see an algorithmic tug of war, yeah.
Yeah.
Maybe even needing defensive balance AIs to help shield us from manipulative, offensive ones trying to knock us off balance.
That's a fascinating, maybe slightly scary thought. Okay, moving to society. Political and social cohesion. AI seems like a real double-edged sword here.
It absolutely is. On one hand, those recommendation algorithms on social media, they're often designed purely for engagement.
Keep you scrolling.
Right. But in doing so, they can create filter bubbles and echo chambers. They sort us along partisan lines, feed us stuff that confirms our biases, and shield us from different views. This can deepen polarization, making us view opponents with more distrust, more animosity. That's a serious social disequilibrium.
Undermining healthy public debate.
Definitely. But on the other hand, AI could be part of the solution. Researchers are working on discourse governors.
Discourse governance.
Yeah, like AI assistants in online discussions. If you type something maybe aggressive or dismissive, it might pop up and suggest a more constructive phrasing. Maybe acknowledge their point first, or could you use more neutral language here?
Interesting. How's that work?
Early studies suggest it can. It seems to improve the quality of conversation, increase what they call democratic reciprocity, basically, being more willing to let the other side have their say. The key is, this kind of balance AI isn't forcing agreement on what we discuss, but trying to restore balance to how we discuss it. Procedural equilibrium.
Okay, from personal to political, let's go even bigger. Planetary health, ecology, environment.
This is potentially one of the most vital areas. AI is already revolutionizing climate modeling, processing insane amounts of satellite data for better weather forecasts, tracking emissions more accurately.
And for ecosystems.
Huge potential there too. Automated monitoring using sound sensors in forests, camera traps analyzing drone footage. AI can track biodiversity, model habitats, even analyze the behavior of individual animals to gauge ecosystem health.
So better monitoring and prediction.
Yes, but the real potential shift is towards proactive planetary systems management. Instead of just predicting, say, deforestation in an area, the sophisticated balance AI could analyze all the interconnected factors: economic pressures, social conditions, ecological vulnerability, and recommend targeted interventions before it happens. Maybe specific microloans for sustainable farming in just the right place, or subsidies that shift incentives, preventing the disequilibrium proactively.
That's a massive vision. But integrating these powerful systems everywhere, this raises an important question. What does all this AI tell us about ourselves, about human nature? And what ethical guardrails do we desperately need?
It really builds up a mirror, doesn't it? AIs trained on our data reflect our patterns, our language, our biases. When a large language model tries to define human nature, its answer is often skewed towards the cultures that produce most of its training data, often Western, educated, industrialized, rich, democratic populations. Weird, as they call it.
So it can mistake a specific cultural view for a universal truth.
Exactly. And, our anxieties about AI going rogue, often that's us projecting our own less than noble traits, selfishness, desire for power onto the machine.
Interesting point. And that brings us back to that nudge versus manipulation idea.
It's a razor-thin line sometimes. A beneficial nudge helps you reach your goals. Manipulation often means the AI exploiting a vulnerability. You're tired, stressed, feeling social pressure to get you to do something that benefits someone else, even if it harms you. Think dark patterns in design, tricking you into subscriptions or purchases.
And AI could amplify those dark patterns.
Potentially, yes, by getting very good at identifying those moments of vulnerability. This demands really robust ethical governance, transparency about how these systems work, accountability when they cause harm, and always, always prioritizing user autonomy. The user needs to be in control. And finally, we have to grapple constantly with bias and fairness. If the historical data an AI learns from reflects societal inequalities,
The AI can end up perpetuating them.
or even amplifying them, hiring algorithms, learning biased patterns, predictive policing tools, correlating risk with zip codes instead of behavior. It's a huge challenge. That's why things like continuous auditing of AI systems and ensuring diverse teams are building them are absolutely essential, not optional extras.
Wow. We've covered a huge amount of ground, from
Yeah.
the basic idea rooted in homeostasis, through the complex mechanics, the need for explainability, the incredible range of applications.
Yeah.
Balance AI really is this vision of a continuous, dynamic governor for systems big and small.
It's a powerful vision, absolutely. But as we've seen, that potential comes hand in hand with some really profound challenges. Technical, yes, but especially ethical. Its success, its legitimacy, it all hinges on trustworthiness. Can we trust these systems?
Which is why having a framework for responsible design is so crucial. We've sort of distilled it down to maybe 5 core principles for building trustworthy balance AI. First, genuine alignment. The AI's goal has to be the real long-term health of the system, not some narrow metric it can easily game.
Right, true systemic health.
Second, minimal intervention. It should do the least amount necessary, acting more like a guide, empowering humans to make the final calls. Subsidiarity and autonomy.
Empowering, not dictating.
Yeah. Third, radical transparency. That glass box idea, we need to see its reasoning, its data, its confidence, its goals. XAI is key here.
No black boxes allowed, basically.
Fourth, continuous adaptation. It has to keep learning how the system reacts to it, adjusting constantly to avoid creating new problems. That meta-adaptation piece,
Learning from its own impact.
crucial.
And fifth, human-centric oversight. Real people, diverse committees constantly checking for bias, fairness, manipulation, unintended consequences. Ongoing auditing.
Humans must stay in the loop, overseeing it.
So Balance AI really puts a choice in front of us, doesn't it? Will we become this opaque tool used to control us, subtly or overtly? Or can it be a transparent, collaborative partner, something that boosts our own intelligence and helps us navigate the sheer complexity of keeping things in balance?
That's the fundamental question we need to answer as we develop and deploy these technologies.
And maybe a final thought for you to take away. As we see these systems develop, maybe even those defensive AIs protecting us from offensive ones, what does it really mean for us to choose our own balance? What kind of equilibrium do we actually want for ourselves, for our society, for the planet, as these incredibly powerful tools become woven into the fabric of our world? Something to think about.
This is DigitView.